or codex. Mm, so why we are building a coding agent from scratch rather than using something like uh, Cloud Code or Codex? Um, First, it's educational, right? For me and all those watching how the agents like Cloud Code are doing so well. Second is the usability. There are some pitfalls in using vibe doing vibe coding using all-purpose agents like uh, Cloud Code to build large projects. The pitfalls are like long-term maintainability, the extensibility of the project, legibility of the code when the code base becomes huge, and over time the features become a bit brittle, right? So the third reason is that it's cost, right? Uh, so I myself spend around $1 to $2 per session with Cloud Code. So instead of depending more and more on the tools uh, where the tools like Cloud Code are getting expensive, I want to build an open source one which can talk to multiple models, and based on the cost, we can select which models we want to talk to, right? And the fourth reason why we are building a coding agent from scratch instead of using something like Cloud Code or Codex is that it initially we'll integrate with frontier models like Claude, GPT, or Gemini, but over time we'll expand to open weight models like DeepSeek, and end goal would be to rely on locally run models so that our coding sessions are a bit more private, right? So these are the reasons why we are building it from scratch instead of uh, using off-the-shelf all-purpose agents. So how do we verify that what we build is useful, right? The coding agent. So for this purpose, we'll be building a production like application from scratch on the stream as well. And so what we're going to build is an application called chesstail.com. It's going to be called Chesstail. Uh, Recently I acquired. Let me show you. Uh, Domain called chesstail.com. So we'll be building this here. Uh, yeah. A one-line pitch of what Chesstail is. So Chesstail turns your chess games that you've already played into memorable, dramatic stories, helping you spot patterns and learn faster by harnessing how our brains naturally remembers narratives. Right? So that is a one-line pitch of chess, the application that we are going to build using this coding agent. For now, I'll leave it at that. We'll come to this when we start building our application. Right. So this is about the project. A quick introduction. Uh, Now let me discuss a little bit of what we have built so far. Right. So this is the repo of what we have built. So it's a CLI based agent. So this is how we invoke it, right? So we run this application. We give it a command called goal, and we select which provider we want, right? And basically this will trigger a agentic session. It will work on this repo, and currently what tools we have built is file system tool, so it can list and read files, right? So we built that from scratch, and we've integrated with a couple of providers already, so OpenAI, Google, Anthropic. So I will show you a quick demo. So if we choose So last stream we completed the OpenAI integration. So if we choose OpenAI, so basically you can see that it is making a tool call and it is reading some files now. Mostly I should, okay, let me kill this and in here uh, hide the tool result content, right? Because this content is usually huge, right? We just show this. Let me run it again. Right. So what is happening in this agentic loop is OpenAI is telling us to explore this directory, right? So it is listing files in the current directory. Now it's reading files one by one, right? And we are sending the stuff back as tool result. And so it is reading more file. So at the end of this session, it should be able to explore this project itself and explain what this project is about. So it will take some time. So as you can see, the final message is that it's saying this is a repository, a Go framework, uh, which has a basic agentic loop, and it's explaining to us what the architecture of this project is, what tools are there, right? So basically, this is an agentic loop that we have implemented, right, in a couple like last 4 streams. All right. Yeah. So what we the agenda for, okay, so let me open the road. So overall, we've done with most of this, right? So last week we supported ChatGPT and Gemini models. So there was an issue in Gemini that we'll start by fixing today. Uh, the issue was that the way we are sending tools is not correct, and that is why Gemini was acting weirdly, where it tried to read the etc password file, right? Thankfully, that is not any secret file, but the behavior is very weird from Gemini's side. So today, after fixing the tooling thing, we will also uh, create some sort of sandbox for this so that the agent cannot read any files outside the project repository, right? Once we do that, then we'll continue with our tooling where, so currently we have list files and read files, right? So we will add a write and edit file, so which will have our first version of sorry, my bad, which will have first version of our agent ready so that we can start our chess app, right? So this is the things I wanted to clear before we move into the thing. So okay, right. So I did some stuff off screen, and let me go through. Uh, Let me close all of this. Right, in the roadmap, what we're gonna do today is create a write tool. Oh, it's already here, right? Create a write file. Search, we'll see, probably we'll not do this stream, right? So this is the roadmap is clear. Let's go and fix in our Google integration, right? So this initialize a new client. This is the common logic uh, where so we abstract our integration with all the different LLM providers with this interface called run inference, right? Which takes a message which is our type and set of tools, and it returns a bunch of images. And so in every implementation we do this, we convert the messages into Google's messages, then we convert in tools, we make the inference, we convert them back to our message types, right? And then we return this message, right? So message is simple. It can be either of uh, a text tool use or tool result, right? So this is how we have abstracted. And the place where we were stuck last stream was the way we send tools, right? So in transform tools, So the way we define tools is just name, description, an instance of the input schema and the implementation function, right? So to show you a simple tool, right? So read file is a tool, the name is read files of the given path, right? And so this is the instance, right? So this is where we define the input of the tool using JSON schema, right? And the implementation function. This is how a tool looks like. So the way we are going wrong here is mainly in this logic, right? Where we take the instance of our input schema, right? And what? So I did some digging of the way Google requires this parameter JSON schema, and it is exactly like what we do for OpenAI. So I'm just going to copy the logic of OpenAI. So what it does is we can take our instance, right? We can use JSON schemas reflector. Right? From that we get some sort of a representation, JSON representation, which is a JSON schema. We convert it back into map of string any, and then we return. So I'm just gonna copy this logic, use it here. So for now, this should work. Let's fix some error. Let's return error so that we don't, so that we know when our tool calling is failing and we can know where to fix. Right? So mostly this should work. Let's fix this. Let's take this and on error, what we do is let's continue, right? We skip this. Let's continue with an error saying print line fail to register tool. Let's also give the tool name. So that we know which one to fix, and let's give the error dot. We use the schema here. Cool. So with this fix, I think our Gemini implementation should also be working. So let me run this again with Gemini. Oh no, its provider is Google. So that is the nomenclature. Right. So what I've also done is I've added the API keys in this file, which I'm not going to open on live stream because it's tokens cost money. So so by giving this here, so it's going to switch on to the Google provider and all the LLM calls will happen to Google and not any other. So let's see how it behaves now. Right. So it's giving the tool correctly. Right. Now I think it's working correctly, right? It's reading the main do file. It's listing directories in LLM directory. So I think this should work now. We'll wait for it to complete. But yeah, this should work. Right. Meanwhile, let's do another thing in our agenda, which is to write a README file. Okay, what we see here is that again, so this agent has gone through this projects and tried to summarize what this project is about, right? So this is actually a good, okay, let's use this. Uh, mm, Now I'm thinking we should complete the write tool and then ask this agent to write the README file itself. I think that's a good idea. That will be first use case of the agent itself. Okay, let me delete this then. Also, I see a number of you online, so and this is supposed to be interactive stream. So if you have any questions, feel free to add it in the chat. Cool. That being said, let's go on to write the edit and read file tool. So what I'm also doing here is keeping the code a bit clean by adding regions. So it's basically just a foldable section, right? So let's do for read file as well. Okay, so we can fold this neatly and we can navigate the code better. Also, this tool map, I'll move it to the common logic, and because this is the only place actually it is used. So when we execute tool in our agentic loop, we give it name and input, and give back string. So the execution is mapped here, right? So this is where the tool map is required. So let's keep it here. Let's start our region for let's write the right file because that's a bit simpler, right? So the way we do it is let's apply file to definition. So this is I'm using GitHub Copilot a little bit, so to make this a bit faster. Given path, say relative to the root project, right? Let's not use absolute path input schema instance. We have to define a struct for this, so we don't have that yet. And then we need function which is write file implementation, right? Write input path and content. Okay, so GitHub Copilot is good at auto completing this kind of thing, so that this is a bit quicker. Input. So we just need to give it an instance. This will be used to do reflection on this and convert this into JSON schema. All right. Now what is remaining is type write file implementation. Okay, so first we get the input and unmarshal it. Right? What's wrong here? This is a function. This autocomplete is a bit weird. Okay, anyways. Okay, so this is write file implementation, and what we do here is get the path. Okay, this is also something we have to do. So if this does not exist, we have to create it, right? And so one of the rule with implementing tool is that whatever error happens, we have to give it back to LLM, right, as form of a string, so that then it can take corrective actions, right? So let's say if it gave a wrong path or a place where writing is not possible, so we just return back the error, right? Create the file. Okay, we have to close it also anyway, right? Okay, this logic is pretty simple, that's why it's happening automatically, right? At the end of the day, we return something like success. And right, so basically what we do is make this a right call. I think this should work out of the box unless there is some any error. So let's just hook it up with our system right file. And the way we give all the tools is here, right? So I think instead of it writing it in both places, actually let's iterate on the tool map, right? For tool range tool map all tools is good, right? So we just have to add it in one place. So this is let's use somewhere. So let's use T. So basically we've written our tool and we hooked it up with our right. Okay. Okay, this should work. Let's see. So so what we say is explore this project and write a readme.empty. Let's use OpenAI. Actually, I like Anthropic a little bit more. Let's default to that. So we are logging few things in our agent loop, and so when it's a text message, we just say assistant. When it's tool use, we say write the tool ID and the input key input. Right. The tool result we are not printing it in the logs because it's usually huge, so we just print the length, right? So as you can see in single instance, there are 3 tool calls, and we are sending the tool results after that. So all of this is happening. Okay. So the next thing what we should do here is we should report costs of how much thing this loop is costing, right? That is the another major feature we are going to build, not this stream, but let me just capture it in the roadmap. Cost and token tracking. So this stream basically we're gonna do so we're gonna do write tool. Let's remove this. Then we're gonna do test. Why is it reading so many files? I think this is stuck actually. Okay, something weird is happening. So it created the file, but it is stuck, it seems. Oh, okay, I know why. Because because I call directory. Okay, this is stuck. Let's not waste tokens. What is happening here? I think because this worked fine. Create right string. Okay, let's debug this thing now. We lost some tokens here. Okay, no big deal. Let's use a cheaper model, Gemini. And this time we're debugging, right? So let's use our debug console. And let's play with this project. Write a dot file. And the provider here is Google. Okay. So we're doing this because we want to debug this thing. We want to see what is why this is not working. Uh-oh. This is okay. It's gonna do a bunch of reading, which is fine. Okay. So now we have a debug point. Right, it's trying to write this. Actually, let's copy this so that we don't lose this, right? Okay. We unmarshal, get the input, we get the path, right? We create the readme file, we do write string. Hey, this is working. Oh, was this working all along? Right, the execution is complete, and then okay. Why did it not work with Anthropic? Weird. File. Weird. In the right file. Content is here, right? So basically, Anthropic is not giving the content, it's just saying write empty file. Okay, we can debug this like differences in how models behave for same prompt, right? So like this will be the core thing that we do because we are supporting multiple models. But for now, what has happened is this readme has been written. So it says autonomous agent in Go. It enables creation of agent that interact with LLMs provider. Okay, not a bad description, but you can features. So let's just remove all of this. Actually, we don't want this, right? Because it's gonna change fast. And then building. Let's keep it simple for now. So getting started, write the file, then you go provider name, example. Okay, let's remove this. Okay, I think our readme file is ready. So that is one thing from our agenda. It's done. And the right tool is also working, right? What we have to see is why it is not working with Anthropic. That is one thing we need to do. Mhm. Okay, let's just debug it quickly. So when we do Anthropic apply, we have to debug the same write file function, right? So it is calling all these things correctly, read file and read and list uh, files correctly. Just not doing the write file correctly. So let's put a debug point there. Okay, testing. Okay, so we got this. This is the problem, right? Why did it call? So Anthropic called this function with just path, but JSON schema description content is empty. This is a bit strange. Let's go up the stack to see what is the response message. Okay, actually we have to debug what tools we are sending this guy. So when we make Anthropic tools, so when we make an inference, we have to see what tools we are actually sending. So let's put a debug point here. Okay, tools, LLM definition. This is fine. Let's see the last one. Input schema is content. Let's check Anthropic tools. Last one. Okay. This bug is taking some time, so I'm thinking should we even spend time here? Schema. Okay, let's check for this should be right file input schema properties pairs content is there. Hmm. This is so weird. So we are sending the correct tool to Anthropic, but it is calling it without the content. Let's do okay. I think this bug best debug off stream. Uh, let's have this here. I will come back to this. I think this is taking too much time. I bet this is some small issue, but anyways, we can continue with our agenda for today so that we don't get overtime uh, without making progress. So, right, let me pull up what I was planning to do. Right. So this is our core agent loop, right? On init session with a goal, uh, we prepare a conversation history, system prompt, and goal. We run inference for each message in the inference result, right? If it is just text, we add it to the conversation history. If it is a tool, we execute and add it to the conversation history. And if there are no more tools in this message, then we finish, right? We finish our session. Otherwise, we do the inference again with a new conversation history, right? So this is our existing one. What we want to add today is this, right? Which is we have to define a software development lifecycle where each session, whatever it does, uh, it is captured as commits on a new branch, right? So this is one way where we want to make an agent which is not just like Claude, right? And this we want to do because uh, uh, so a lot of time in vibe coding, what happens is we give it one instructions after another, and overall all that code is in the current working directory, right? And so some of it we want to revert, right? But since all of it is in one, it gets messy quickly. So what we want to do is we define a process in which every session we create a branch as a side effect of init session, right? We do all of this. If there is a write tool happening, we make a commit for every such write happen, right? uh, and at the end of the session there is basically something like a PR which we can review and merge. So this is the initial idea I have for having a like a coding agent where it each session is a clear. So what will happen is over time, as we use more and more agent for our project, we can go through the history, and so the agent itself can go through the history and decide which abstractions to keep. So why we did certain things certain way, and if we want to refactor which abstractions to keep, which to not keep. So this is the initial idea of so let's start that. Okay, sorry, wrong screen. So what we've said is on init of each session, we will create a git, right? So this is where we start our agent loop. So what we're gonna do is here we want to do, so we want to do git init if it's not uh, an existing git repository, right? And then we want to create a branch. let's start here actually. Then we can continue. So for that, what we have to do is let's see which Git library we can use. Uh, or codex. Okay, readme file is gone. Okay, where do I in the main loop? Git init, right? So git init. Let's see some documentation of how to use it. Actually, let me try to get actually let's just use ChatGPT for this. Otherwise, we will be spending a lot of time here. Clean init path. Okay, let's do it. Let me keep this on this side so that I can read and work parallel. Right. So root part is, so we'll just assume that the is always initiated here. Plain init and is bare. What is this bare? Let's keep it false. Yeah, there is some getting used to this library. Just ChatGPT how to do it. Okay, let me just copy this part instead of writing this from scratch. Right, so this function is get or init repo. So what it does is ensures repository is present. It will open to get open. If it does not exist, it will do init. Right. So this is the logic we want. We have a repo. We want to create a branch. Just create a branch, get the head of the repo, use the hash to create a branch with the branch name. So what should be the name of the branch? So at this point, actually, we don't have any idea what the name should be, right? Ideally, it should be some meaningful name given the goal, right? So actually, we should make another inference here. Name, right? For now, we can actually just say branch name is feature. Right? We can just hard code it for now just to check. So these are fatal errors, so we don't want to do anything here. Right? Create a branch. Right. Okay. Now for the right hmm, we want to share this repo object with our right tool, right? So that's gonna be a bit tricky. I'm thinking let's create a git helpers. Let's move some things here so that we just initialize the repo once and we share this repo object everywhere as a static variable. repo git repository, right? The function would be init. Why should we do this? Get or init repo. Let's panic. So we have this here. I don't have to do anything here. So git helper.init. Don't need to pass repo. The repo is now in our tools for the right one we have to write commit message as JSON as input, right? And when we do this, we have to do repo dot. Let me get the code for the logic for add all and commit, right? So get the working tree, add with options, make commit, right? Author's email, okay. When? No. Okay, this makes sense. Add and commit. So in our tools, in our right tool, implementation, we have to do git helpers, add repo. We're not gonna pass, right? Commit message is gonna be input dot commit message. Now author will be, let's say, agent framework, and author email, let's say agent framework. And I have this domain appeal to file. Okay, this looks good. Right. Now let's do go install. What is the name of this one? Let's do go install. And use this in a new repo called just tail. Right. Just tail. Ancient framework. Okay, I think the environment file is not gonna there, so this is not gonna work. So what we have to do is change the working directory here and execute the same. Yes, right. And instruction will be okay. Let's keep it at that for now. I run this. Let's open this thing actually in a new folder. First project. Okay, so this is an empty repo. Now we have to see whether it is able to write. Let's again debug. Okay, this is a problem, right? So the working directory should have the .in file. Okay, let's fix this. Absolute path. And let's do this. Load L file string, right? In the run, copy absolute path. Okay, this should work. Okay, fail to create branch, reference not found. Okay, I think so. Just init happen, I think. Reference not found. Is this variable not present to this? Is it not initialized correctly? Because okay, it looks like we are out of time for this stream. We already crossed the 1 hour mark, and also we're a bit of uh, stuck here. So I think it's a good place to stop and continue next stream. So yeah, for closing, thanks everyone for joining this stream. We'll continue next week with completing our right tools, and everyone have a happy new year. Thank you.